Hi guys, I hope you're all doing well, and welcome to the webinar in which we will, which is effectively the launch for the new robot arm from Matrix. Thank you for joining. Like I say, I am recording this webinar, so I will send you a link to the webinar after the webinar. And basically, what we're going to do today is I'm going to go through exactly what the new robot arm consists of, who can use the new robot arm, key features and benefits. I will then do a bit of a demo on one of the new key features, which is called pendant mode. And then there's going to be a chance for you guys to ask any questions, that sort of thing. In the presentation, there are some slides. I will send those as well. So yeah, you will get them. Someone unmute themselves. I have muted everybody, so if you want to unmute yourself, if you've got any pressing issues or pressing questions, alternatively, if you want to put something in the chat, questions in the chat, I will get a chance to answer the question. Yeah, I will mute everybody now, and if you want to ask a question, please just unmute yourself, and we'll go from there. Okay, I'm going to start off by playing you a small video, a short video that's about our robot arm. Okay, thank you. Bear with me, guys. Just getting used to the technology.
The Matrix AllCode Robot Arm Production Cell is our new version 2 robotics offering that can add significant value to any manufacturing engineering, computer science, or robotics course. The system comprises of a rugged, stepper motor controlled 3 degrees of freedom arm, bolted to a base and supplied with activity mat that provides a range of exercises to replicate an industrial robot arm. The robot can be used by students to learn about arm movement and construction, pendant programming, GCode programming, API programming, microcontroller programming, sensors and actuators in robotics, and kinematic systems. The system can be connected via a Windows PC, Raspberry Pi via Linux, Apple Mac, Android mobile devices, a programmable logic controller or PLC, and much more. Users use a Bluetooth or Wi-Fi connection to then control the robot from multiple programming languages such as Python, App Inventor, Flowcode, C++ or C# or LabVIEW. The Wi-Fi connection capability means that the robot arm production cell can also be used as part of a remote lab, perfect for distance or blended learning. The kit is supplied in a rugged storage tray, and a free instructional guide including worksheets can be found on the Matrix website within the Learning Centre. For more information, do not hesitate to get in touch.
Thank you. I hope that that was useful. I'm just going to go to the presentation now. I will also send you a link to that video if you want to send it to colleagues or have a look again at a later date. That's fine. Okay, so what we're going to cover today, just a quick look over. We're going to look at some key features of the new robot arm, the specification of the new arm, where you might use this robot in which departments, and we're going to look in detail at the curriculum, and we're also going to look at a product that's coming soon. Okay, So the new robot arm has been improved on, on all fronts really. First of all, and one of the main improvements is the improved ruggedness. Okay, so it's now a lot more robust for learning and for the educational environment. It uses stepper motors. It's got 3 degrees of freedom and much more powerful stepper motors. The previous one we used servo motors, and the upgraded to stepper motors really adds to that rugged, student-friendly outlook on this new robot arm. Okay, so that's one of the improvements. Another major improvement is in the curriculum. Okay, so the improved curriculum allows you to use the robot in different departments now. So, for example, it can be now used in higher education, so university, because there is a lot of worksheets on kinematics and design of robotics. We've also introduced a new pendant mode, which allows manufacturing engineering departments to use the robot as well. So you can program it via GCode in this pendant control, which I will show you in maybe 5-10 minutes. We've also added new ways to connect to the robot. So before it was done over Bluetooth or USB. You can now connect to the robot via Wi-Fi and CAN bus, which is quite nice, especially for things like Internet of Things. But I will touch upon that shortly. Okay, so I've mentioned some of the key features already. The increased rigidity is something that we find, is really crucial. The new robot arm has 3 degrees of freedom. It's compact and portable. Now, you guys may know quite a bit about Matrix, but one of our key ethos is that a lot of most of our kit is compact and portable. So you don't need a specific or a lab that's just for that product. The robot arm is portable, so you can use it in a normal classroom, or you could use it, or it can also stay, where it is. So it's compact and portable. It does actually go into the grapnels boxes that most of our products do. It's supplied with AllCode technology, which is something that some of you may be familiar with. Our AllCode robot buggy uses a similar technology, AllCode, and our previous robot arm also used AllCode technology. This means that you can use multiple software programming languages that you may be familiar with: Scratch, Python, C++, C#, whichever the student or the lecturer is comfortable with to program the robot. And that's very unique to Matrix. The robot also comes with 3 PC apps which are supplied. One of them is for the configuration of the robot, okay? So giving it an IP address, that sort of thing, giving it a Bluetooth password. One's open control, where you can basically use any programming language to control the robot. And the other is pendant programming, which is brand new. Pendant programming, basically, I will actually show you that. So don't worry too much about what pendant programming is for now. Obviously, another key thing that we've added to the robot arm is this: the fact that you can control it remotely via the internet. Okay, so it's the Internet of Things and connection via internet, which is obviously crucial at the moment with everything that's going on. Lack of student times with the lecturers. The students can actually control the robot arm now at home. Very important for distance learning. Also, like most of our products, it's all operates at a very safe voltage. I think it's 12 volts. Okay, so now onto the specification. I'll show you the robot arm in just a moment, but it has a rugged bolted to the base, which slots into the like a jigsaw type mat. I've mentioned the different ways you can connect to the robot arm. So Bluetooth and USB, which is similar to the old robot arm, but also CAN bus and Wi-Fi and new. It's got base rotation, shoulder and wrist rotation, and it's also got a functional gripper. It comes with a mat which you can leave the robot on when you're not using it, or you can pack away into the box when you're not using it. The mat has the coordinates for the X and Y coordinates and axes. It's got several different worksheets that I will touch upon shortly as well. Supplied with a comprehensive manual, so like most of our products, we have a learning center, and this comprehensive manual it allows you to choose which programming language you're using to control the robot arm, and the manual has a set of teachers' lesson plans, but it also has student handouts. I will send you that after this this webinar. Like I say, that's completely free, and it does a lot of the work for the teacher. Doesn't replace the teacher, of course, but it just gives the teacher a good starting point and where to begin. Within that curriculum, it's got examples for C++, LabVIEW, Python, App Inventor, MATLAB. So, you know, the example, I've just got a chat, 1 second. So it's from Jeff. When you say 3 degrees of movement, are you saying 3 directions? I will actually go on to that shortly. Thank you for the question. I'll show you what we mean by 3 degrees of movement when we actually look at the robot in maybe 2 or 3 minutes. Good question. Now you can control the robot via PC as normal, or Linux or Raspberry Pi, Android, Apple Mac. So there are various ways you can control the robot arm. The robot arm is actually it's a powerful DSP with several gear motors attached to that. 1 servo motor, which is for the gripper, and 3 homing switches. Different to the last robot arm, instead of the 3 main stepper motors being servo, they are now stepper motor. So they're a lot more accurate than the last robot arm, and they're a lot more rugged and strong. It's also got an integrated color sensor attached to the robot arms for things like pick and place and that sort of thing. So, where can the new robot arm be used? The old robot arm could actually only really be used in robotics and electronic engineering. That's no longer the case. Okay, so now we've opened it up through some new software to be able to be used in manufacturing engineering as well. So typically the robot arm has been popular with the ages of 16 to 18. Due to this development of our curriculum and also the development of our new software for pendant control and curriculum changes to allow it to be able to use at degree level, you can now use the robot arm beyond the years of 18 quite nicely and quite well. It is suitable for manufacturing engineering, where learners will use and learn how to program the robot using GCode, which is brand new to our robotics section. It can also be used at degree level when we start to talk and learn about designing of robots, the kinematics of robotics. So because you can now use it in manufacturing engineering, robotics design, it's a lot more cross-departmental, which is great and obviously ticks a lot of boxes, particularly when you're applying for capital bids and things like that. Okay. So the first section is in a robotics class or in a robotics unit within your qualification. There's generally a need to learn to program an industrial robot. Now, I have got a lot of colleges that are using our robots as the industrial robot or as a stepping stone before they use it on a bigger robot. Okay, so there's two types of people here. One type where, again, they will use our robot as that industrial robot or as a stepping stone. So they will use our robot, which uses the same techniques and learning outcomes, but then they will use a bigger robot when it comes to the final assessment. So as that intermediate step. Our robot can be programmed through the API via many languages. In a robotic sense, they may use something like Scratch or App Inventor or something like our software flow code to program the arm. Also within the robotics section, we do have a Formula AllCode robotic buggy, which I will send a link for after this webinar to you guys. So yeah, in terms of robot or in a robotics unit, we do feel that you would program the API and then use something like App Inventor, Scratch or flow code. If you are using the new robot for electrical or electronic engineering, in an electrical or electronic engineering sense, this is where the user is a lot more likely to use the actual microcontroller and program the actual microcontroller rather than the API. So you'd use Python, GCode, MATLAB, LabVIEW, and there are various worksheets which are in the lesson plans. I mean, typically you'd use, I think maybe Python here. There are, in the worksheets, it goes into actual specific programming languages. So here on the right-hand side, you can see, gives you examples for getting started with LabVIEW in this example. And there's a range of worksheets here, for example, color sensing, pick and place, sorting, simple production, that sort of thing. This is new. So manufacturing engineering. The previous robot arm, we didn't really fit into manufacturing engineering because you couldn't use pendant programming or GCode programming. Now, this is manufacturing engineering is an area that Matrix is expanding into all the time. This product will add to our pneumatic range, our micro CNC range, but on the horizon, we are also very close to launching a product or several products for process control, flow and that sort of thing. But we're also going to release a product which is a smart factory. So a factory with a factory pick and place, gantry, sorting and that sort of thing. And there is a slide on this presentation on that. And the robot arm actually works in unison with that. So manufacturing engineering is an area that we are looking to develop in the future, and this is a key reason why we are looking to move into manufacturing engineering. Okay, so here in manufacturing engineering, the students would use the robots to learn about the axes, which are important. They learn about how to program in GCode using the all-new pendant programming mode. And they would learn about the workplace and the limitations of the robot, the accuracy of the robot. That's all the key learning outcomes in a manufacturing engineering technician level unit. The next place where we see that the new robot may be used is in robotic design, so degree level, HND level. So here the learning is very much about the geometry and the kinematics of a robot. For example, the students must do some maths and some calculations, which converts a stepper command in steps into the angles for each joint. And also in the robot design market, the user may want to reprogram the microcontroller itself using something like C++, C# or MATLAB. etc. So curriculum, as all of our products with at Matrix, we provide curriculum. It's in depth. It's written by practicing teachers. They're done in a manner that students will find, very intuitive. This particular curriculum for the new robot arm, covers many different languages that the user may want to program the arm using. For example, LabVIEW, Scratch, Python. The specific worksheets included include manual movement, path following, automatic sorting, through to complex movements, automatic pick and place, API control, and recording paths. Now, pricing's it's a bit awkward. We're going to put a recording of the prices, a recording of this webinar onto YouTube, and therefore we're not going to publish any prices because they're susceptible to go up occasionally, although we don't do that regularly. But also, we have a chain of resellers throughout the world that will sell at different prices, and therefore we're going to keep the prices to ourselves. I will send prices privately to you guys upon request. And also, if you'd like me to put together any lab suggestions for different labs, for example, robotics, microcontroller, electrical engineering, or manufacturing engineering labs, please just request that, and I will I will go into what we would recommend. Okay, so on the horizon in the next 2 to 3 months, we have a new product which is our smart factory. We've been developing this for some time now, and we're delighted to say that we are very close to being able to release this. The smart factory has full compatibility with the new robot arm. Sorry, I'm just going to have a drink, 1 second. It's got complete compatibility with the new robot arm so that they can work in unison together. It's also got complete compatibility with Siemens PLCs, namely the S71200. So you can program it via the Siemens PLC or our PLC, or indeed any PLC that you feel comfortable with, Omron, Bradley, etc. Yeah, you can program the PLC to control factories and processors. This will include things like color sentry. There's a gantry on there, smart sensors, and several other processors that you're likely to find in a factory setting. So watch this space. I will probably do a webinar on this smart factory once it is ready for release. And yeah, watch this space because it's quite exciting for us. Okay, so next, I'm going to stop share and I'm going to do a demonstration with you guys, which is using the pendant programming. So give me just a moment. Share screen. Okay. So this is your typical screen in pendant control programming. Now, if you are or your students have got to learn how to program something via GCode, the likeliness is that they'll have to do this on a form of tablet. Now, this here replicates that tablet, okay? So if you were to program an industrial robot, the likeliness is they will be doing it via this tablet, or a tablet similar, where they have to punch in their commands and type in a series of G-code commands. This is very similar, but it's just done on a PC or a laptop. Okay, so I'm going to start from the beginning. Give me just a moment while I set up the camera. I believe you can now see the camera. Okay, so what I'm going to do is I'm going to delete this program here. Running down the right-hand side is the connections, okay? So you can see here the way the different communication methods you can use to connect to the robot. For this particular one, I'm going to choose Wi-Fi. I then will type in the ARM's IP address, which I specified earlier, and the port 1245 for this specific robot arm. Now, earlier, Liam, my manager, was connected to the robot at his house, which is 10-15 miles away from here, over Wi-Fi. Here, I'm actually sat right next to the arm, but it's still connected via Wi-Fi. Now, I'm going to basically just do a simple pick and place set of commands for the robot arm. I hope you can see the robot arm. If you cannot, please could someone unmute themselves now and say you can't. If no one does so, I will assume you can see it. Now, in the back of the curriculum, there is a section that tells you and helps you with the G code. Okay, so the first step in any G programming mode is that you need to tell the robot to go to the home location, which I know is G28. Okay, so this G28, this homes all the motors back to their known origin location. I then need to add a new line, and I need to open the gripper to its full. Okay, so M6 here opens the gripper. M6 controls the gripper. The gripper servo motor that operates the gripper ranges from 0, which means closed, to 250, which is its maximum open. For this specific, I just want it as open as possible, so I'm going to type in there 255 and click OK. I then need to add a new line, and what I need to do is I'm going to tell the robot arm to move to a set location within an X or Y, with an X, Y, Z location. So I've got several options here. I can go rapid move, or I can just click move. Rapid move is basically a movement to an XYZ location at the predefined speed of 8,000. If you were to choose G0, which is just move, you can then define the speed. But for this, I'm going to just click rapid move, and the X. If you just see on the camera here, this here is the counter that I'm wanting the robot to pick up. So I basically need to read the X, Y, and Z axes to find where that counter is. Okay, so for the X axis, it is 220. So I click 200, I type in 220, and I click OK. The Y coordinate is 180. So I type 180, OK. Now the Z coordinate is horizontal from the mat. So it's upwards in millimeters. So if I was to type in 100, that would be 100 millimeters above the mat. That sounds about right for now. So I type 100 and OK. The next thing I need to do is add a new line. At this point, the gripper, or the hand of the robot arm, will be 10 centimeters above the mat. I now need to just tell it to dip down to the correct place where the counter is. So I type in again, rapid move. The X and Y coordinates will stay the same. So 220, X, the Y is 180, and now the Z coordination of 12, because it just needs to go towards the mat by 9 centimeters. So it goes to 12. The next thing I need to do is, this is basically the robot arm will actually have the the counter within its grip. I just need to program it to close the gripper. So I will go to the gripper, which is M6, and I want the gripper position to close to 75. I know that through the configuration and knowing the position to hold the counter. So I click OK, and I click Add. The gripper will now be closed with the counter in between at the initial position. And I now need to tell the robot arm to move upwards. So I type, I'm going to, for the purpose of this demonstration, click G1, which is move. And I want the X coordinate to stay the same at 220, the Y coordinate to be 180, but I want it to move upwards horizontal on the Z axis to 50. So I click OK. It's now asking me the speed, the movement speed, because I clicked just move instead of rapid move. 0 is the slowest and 10,000 is the fastest. I'm going to go 1,000, the speed 1,000, just for the purpose of this demonstration. I now click add, and I now need to tell the robot arm to go to a location over here on the right hand side. I don't know if you can see this one, this location here. So the X coordinate, I'm going to click rapid move. The X coordinate, I want to be minus 210. The Y coordinate to be 200, and the Z coordinate to be 100. Rapid move, I'm going to add and go rapid move again. The X coordinate stays at 210. The Y coordinate stays at 200, but I want the hand to drop by about 9 centimeters. So the Z axis to dip to Z12. And then I want to add a new line, and I want the gripper to close and drop the counter. So I click M6 for grip, and I say I want it to open to say 150. I then add another line and click for the robot to go back to its home position. Now, that I think is the complete program to pick up a counter and drop it off at another location here on the right. Now, with any demonstration, there is always a chance that I get it wrong because it's a demonstration. But let's just see if this works. I'm going to click run. Fingers crossed for me, guys. I'm just going to stop the sharing of the screen. Let's see. So far, so good. Should drop it here at W. So now the gripper will open and the robot arm will return to its home position. Thankfully, it worked a treat. It worked absolutely fine. So that is just a short demonstration on how you could program the robot in this new pendant control using GCode. I'm now going to just take the camera and zoom in a little bit to show you a couple more bits on the robot arm. Give me a second. I'm just changing the microphone. Da-da-da. Okay. Okay, so I'm just going to zoom in a little bit here, guys. You can see, as I mentioned earlier, you've got the X and Y axes there. Zooming in on the actual robot arm, you can see here there is a color sensor. So within the curriculum, there are some
there's some lesson plans and teachers' notes and worksheets where you're learning how to pick up the counters, take it to the color sensor and sorting respectively. Here you can see there's the DS pick. The color sensor gets plugged in here. There you've got power. You've got the USB there. The various, you've got this here turns, as you can see, that's the shoulder. You've got the elbow, and you've also got the gripper there as well. Now, you can see that the robot arm mat is underneath this sort of acrylic, which comes up nicely into, it's like a jigsaw, essentially. Just so that you can move things away, pack them away, and that sort of thing. So that's the robot arm. I am going to ask for questions now, depending on whatever you've got. I'm going to see if anybody's posted any questions into the chat section. Now would also be a good time to unmute yourself if you've got any questions. Give me a second. Okay, I'm just gone a bit blurred there. 1 second. Why have I gone blurred? For some reason, I've gone blurred. I don't think it matters too much anyway. I've got one question from Kev Donnelly. Thank you, Kev. Let me just change the microphones. So, do you have to define the coordinates that are not altering? The answer is yes, you do have to do that. You have to define the coordinates that are not altering. Yes, that's right, Kev. Any more questions, guys? Okay, yes, I've had a question privately that's come through, which is about packaging. How is it shipped? Yes, okay, give me a moment. I will just go get you and show you how it's exactly how it's shipped. For some reason, my camera has gone blurred. Anyway, as with all of the Matrix products, it comes in these deep trays. It fits perfectly in here. This is what we call an extra deep tray. Comes with all the crash foam and fits perfectly in there. Now it also comes with accessories, in which is a shallow deep tray. So even the mat fits into here, the acrylic jigsaw that sits on top of the mat, the counters, the USB lead, everything fits into these boxes, and they can be stored away nicely. And that adds to the fact that you don't always have to have a set robotics lab. You can just use it in any classroom, really nicely, and transport it from classroom to classroom. See if I've got any more questions. I've got a question from... Kevin, it should be relatively straightforward to further develop the pendant program mode to allow for line edit too, so your students did not have to define each new line of G code. So also a copy paste type function would help with that. Any more questions, guys? I'm gonna wait a couple of minutes, guys, in case there is any more questions. please feel free to unmute yourself or ask any questions in the comment box. I'm finally not blurred again. Yeah, unmute yourself, or if you've got any questions, put them into the comments section. I'm going to give you another minute and a half to answer any questions you may have. Just whilst it was blurry a minute ago when I was showing you the storage solutions, I'm just going to show it you again. So it comes in this rugged container, whereby which it's got this foam cut out to make sure it's very safe and it's not going to get damaged in the box. And it folds away into this cutout. And because it's this grapnels type storage, they can be stored very neatly away into a space that, you know, it doesn't take up much space. You know, it's not very heavy. You can move it from classroom to classroom. It comes in this deep tray and a shallow tray. So the shallow tray is here, and in there you get all of the accessories. So you've got your mat, your color sensor, your jigsaw on top. So yeah, it comes in a deep tray and a shallow tray. I've had a question from Ivan. Yes, to answer your question, there is a possibility that we could use the new mat with the old robot. It's something that if you are, you know, interested in, we can have further conversations after this webinar to discuss how that would be possible. But yes, it is possible. I've had a question from Tony. Yes, some of the components for this robot arm are actually 3D printed. You are right. So, you know, it makes it a lot easier for manufacture. Yes. We don't anticipate that, you know, as I said earlier in the webinar, we don't anticipate that this robot is going to get damaged very easily. However, as Tony has suggested, some of the components are actually 3D printed. So if in the rare occurrence it did get damaged, we can send you the drawings if you wanted to then 3D print the replaced component. That's no problem. So yeah, we can provide drawings of 3D printing sections. As I mentioned earlier, obviously, you know, it is very unlikely that things are going to get damaged. All of our products are designed for education and ruggedness and how strong the product is real high priority for us and high on the agenda when we're designing new products. So, like I say, we don't anticipate that this product is something that's going to get damaged very easily. However, in the rare occurrence it does, we can send you the 3D print, or we can even just send you some new components or parts. I'm going to give it 30 seconds, guys, for any more questions. And then if there aren't any more questions, I will end the webinar. Now is the time to speak up if you've got any questions. If you've got any questions that come to your mind after the webinar, please just send them in an email to myself or one of my colleagues, and I'm sure we can help you. But like I said, 30 seconds and I'm going to end the webinar. Okay, cheers. Okay, guys, it looks like there are no more questions, in which case I'm going to end the webinar here. First of all, thank you for all joining the webinar. I hope you found it useful. I hope you're as excited about the new robot arm as we are, because we really do think that it's going to be very popular. We've already made quite a lot of sales in the lead up to its launch. If you've got any questions, please get in touch with me. Prices, if you need any lab suggestions or that sort of thing, please get in touch. In the next hour or so, I am going to send the recording of the webinar, the slides, the curriculum, and a link to the product. So if you do have any questions, please just reply to that email, and I will do my best to answer those questions. Thank you very much. Have a great evening, and speak soon. Cheers. Bye.